Okay, so this is a specific type of design problem. It's a classic design problem. I really like these problems for two reasons, because you have to know how to design a state machine, plus you have to know how a shift register works. So essentially this problem is to design a 2-bit right shifting shift register with a couple different inputs there using a state diagram. And so let's do this thing. If you read this problem, it has first I'm going to start off with a black box diagram, of course, just to get a hold on these inputs. So we'll make this FSM. I'm going to call it, it's a 2-bit, and so the output's going to be 2. I'm going to call it Q, and it's the inputs here has a clock. What else does it have? It has an H for a hold. It has a D input, and I think it has a reset. It has a reset. Okay, so there are my 4 inputs, my 2 outputs. The Q is, once again, is the state of the shift register. And so, okay, well, so the first thing to note in these problems is, because it's a 2-bit shift register, it's going to have a possibility of 4 states, which comes from the fact that 2 raised to the power 2 is 4. So the way I like to start off all these problems is to draw those 2 states, and so I'm going to draw those right like this, try to keep it somewhat neat. I think I could draw circles with this, but I'm not going to go there. Okay, Q equals 0, 0, Q equals 0, 1, Q equals 1, 0, Q equals 1, 1. Okay, there are my 4 states. First thing I need to do here is realize that I'm going to put in the reset before I forget. And I think the reset is asynchronous, goes to the 0, 0 state. So I'm going to say reset goes to 0, 0, and that looks good. Next part in these problems is I like to think that do the easy part first. So there is a hold input, and when the hold input's asserted, it's going to stay in the same state. So by all means, the next thing I'm going to do is go to the state diagram and list some self loops here, and all those have the basic condition of when the hold is asserted, it stays in that state. Okay, so next thing to do in this problem is to start somewhere and fill in the rest of the states. Now, one thing to notice is, because there are essentially 2 inputs to this thing, not including the clock and the reset's special because it's asynchronous. There's 2 inputs here. That means there's a possibility of 4 different transitions leaving each state, and that's going to be my check for to make sure I've completed each of these states. Okay, so in this case here, in this 0, 0 state, what I'm going to say is what's going to happen when, I've already handled the hold part, what's going to happen when D is a 1. It's shifting right. Remember, right shifting is that direction. It's shifting right. If D is a 1, it's going to shift the 1 in on the right side, and it's going to be like this. It's going to transition to this 1, 0 state, and it's most importantly here, I need to include the fact that the hold is no longer asserted. Okay, so that's one input for the D equals 1. When D equals 0, it's going to do something else. And the question is, D equals 0, it's really not going to change. The state's apparently not going to change, or you can say it's going to change back into the same state. So this is going to appear like this. Okay, and I think I'm done with that state. I know there's only looks like 2 arrows are leaving it, but the fact that this upper condition here, it actually represents 3 arrows, and I think I can prove that down here. So H times D plus D bar, and D bar F8 plus H bar. This is all the math that I need to do. If this is H, D plus H, D bar plus H, D bar plus D bar, H bar. Okay, so two of these are repeated. So there's 1, 2, 3, 1, 2, 3. There are my 3 arrows associated with this one self loop up here. So there's the heavy duty math in this thing. Okay, so I'm continue on in this thing. It doesn't really matter which state I go to. I will go to this 1, 0 state. So it's 1, 0 state, and D is a 1. Coming on the left side, it's going to transition to this state. So this is H bar D. Okay, so this one here actually becomes this one over on the right side when I feed a 1 into that thing. The other question I can do on this thing is, if I'm feeding in a 0, which is D bar, where does it go? That D bar is going to be the next left input, so it's going to come up here. This is H bar, D bar. And so there's essentially 1, 2, 3, 4 arrows leaving the state. I'm done with that state. Let's do this 1, 1 state here. I know there's going to be self loop here. Oh, I already got a self loop there, so I'm not going to put another one. So it's going to stay in the state when it's held, or when it has AD coming in here. So if it stays in this 1, 1 state when I'm holding, or when I'm not holding, and the input's a D, I represent that with an H or D. Okay, so there might be a 0 coming in here. In this case, 0 comes in on the left side, and this is going to be a H bar, D bar. Okay, and for the same argument that this up here represented 3 arrows, this represents 3 arrows also. Okay, so I'm almost done. I'm in this 0, 0 state. If I get a 0 coming in the right side, I'm going to transition up into back to the 0, 0. This is H bar, D bar. If it's a 1, I'm going to have H bar, D. And I believe I'm done with that problem. Okay.